Okay, hi class, Mr. Morgan coming to you, talking about lesson 4.5. Lesson 4.5, talking about isosceles and equilateral triangles. Your homework for tonight is right here. This again is due 11/21/14. Don't forget, take some notes so you can use those on your homework assignment. Okay, an isosceles triangle, a triangle that has two equal sides. You know that already. Now, because it has two equal sides, then we know this. The theorem says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So, if we know we have an isosceles triangle with two sides congruent, then the parts opposite those sides are also congruent. Now, the converse. How do you find the converse of this? Well, converse means to switch. If we're going to switch them around, switch the if part with the then part, it would look like this. If two angles of a triangle are congruent, then the sides opposite those angles are congruent as well. So we move that in and talk about a couple more things. Bisectors. The word bisector, again, cutting in half. A segment or line that cuts an angle in half, because we're talking about an angle bisector, or it cuts it into two equal or congruent parts. A segment bisector is a segment or line that cuts a segment in half. Theorem. The bisector of the vertex angle of an isosceles triangle is the perpendicular bisector of the base. Now, what does that mean? Well, that means something like this. This angle right here is called the vertex angle. Okay? If I draw a line so it cuts that in half, then when it comes down to the other side, it's going to also cut that segment in half. So not only will these be equal, but also these pieces down here will be equal. Okay? And it's perpendicular, so it makes a 90-degree angle at that point. We're going to apply that in a couple examples here later. This example, find triangle RST, the big triangle RST. Why is that isosceles? Well, because, again, if it's isosceles, looking at this little triangle, VWS, that's isosceles, therefore the base angles are congruent. But these two, R and S, are congruent, making the sides RT and TS congruent. So we have two congruent sides. We have an isosceles triangle. Look at the next answer. Find X and Y. Number one, if MO bisects the vertex angle M in half like it does, then that's the perpendicular bisector. We know that already then. We also know that this is an isosceles triangle. So those would be congruent, leaving us at this angle right here would be 63. We already know the value of X, it's 90. The value of Y, well, 90 plus 63 plus Y is equal to 180. Okay, that's 153 plus some number Y is 180. When we subtract that, you get Y is 27. So our angle up here is 27. We have another example similar to that already. Again, we have the perpendicular bisector, MO, making X equal to 90. And if we want to find Y, we've got 43 plus 90 plus Y is 180, and this time Y would equal 47. Okay, corollary, something that's a spin-off of the original theorem. If a triangle is equilateral, three sides are equal. That means it's isosceles. It's a special isosceles triangle. Then the triangle is equiangular. Three angles that are equal. And then the converse. If a triangle is equiangular, then it is equilateral. Now both the original statement X, original statement here, and the other statement are true. Therefore, we can write a biconditional statement. And that biconditional statement would be like this. If a triangle is equilateral, then it is, if a triangle is equilateral, if and only if the triangle is equiangular. Couple more examples right here. First of all, we want to find x, so we have an isosceles triangle right here. If that base angle is 50, then that one is 50, and x plus 50 plus 50 equals 180. And when we solve that, you get x is 80. On the other side, y. Well, this angle is y, then this angle up here is the same also. So we have y plus 100 equals 180. So we got 2y plus 100 is 180. And when we solve that, then we get y is 40. Subtract 100, divide by 2. In the other problem, right here, okay, we know the inside's 180. So we have 60 plus y is 180. So y plus 120 equals 180, and y would then be 60. So it's an equiangular, meaning all these sides are equal. They'd all be 4x. If they're all 4x, then 4x plus 4x plus 4x is equal to the perimeter 54. Solving this time, we got 12x is 54. We divide both sides by 12, and you get 4.5 for the side, for the value of x. We have two more examples. If the measure of L is 58, if this is 58, find LKJ. LKJ. We want to find the big angle up here. Find LKJ. This is an isosceles triangle. Therefore, the base angle on the other side is also 58. So if we want to find the big angle, LJK, we can simply do this. 58 plus 58 plus angle K is equal to 180. Angle K plus 116 is 180. And we subtract, you get 64. So LKJ would be 64. Now that's not the only way you could do that. You could also do it this way. You could find one of the small angles. You could find the small angle and then multiply it by 2 to get the large one. Example B. If the measure of JKM is 48, then find the measure of angle J. If the measure of JKM, that's just this part, the little part here, is 48. Okay, we want to find this. We already know that that's a perpendicular bisector, so we know that's 90. So we have 90 plus 48 plus angle J is 180. And we solve for angle J, so we got 138 plus angle J is 180. We subtract there, we get angle J is going to be 42. This time we are filling out the reasons of a proof. It says begin with the triangle PRQ with the angles P and angle Q congruent to each other. Right here and here. Draw angle or draw A, the bisector PRQ. That would be RS. Okay, so we're drawing RS into the problem. Given angle P is congruent and RS is the bisector of angle PRQ. Prove that two sides PR is equal to QR, congruent to QR. RS bisects this angle PRQ. Okay, that's given. We drew that in. That's given. Angle PRS is equal to QRS. PRS is equal to QRS. So PRS, this angle here, is equal to that angle. Why is that true? Because that's the definition of an angle bisector. We know that's what it does to the vertex angle. Angle P is congruent to angle Q. That was given. RS is equal to RS. There again, when that side, that shared side is congruent, that's called the reflexive property. The two triangles are congruent because of angle, side. If the two triangles are congruent, then PR is congruent to QR, but corresponding parts of congruent triangles are congruent. So we proved that the sides were congruent. And that's it. Don't forget, make sure you have the homework for me on Friday, page 213. Thank you.